Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. Today, we are going to talk about how you can make federated query with RDS PostgreSQL from Amazon Redshift. So let's get started. So if you talk about Amazon Redshift, it has some very great features in place in order to access data from other sources. So for instance, Amazon Redshift Spectrum can be used to query data from S3 buckets inside Amazon Redshift, or you can use also Amazon Redshift data sharing mechanism to query data from other Redshift clusters into one Redshift cluster. And if you want to learn more about these two features, actually I have created one video and exercise for Amazon Redshift Spectrum in my channel, which you can watch, and I have also created one demo and a presentation for Amazon Redshift data sharing, which you can use to learn about data sharing features. So these two topics I have covered in my YouTube channel. You can look for these topics in my channel. You can search into my channels and you can watch them. But today I want to continue this story of accessing data from Amazon Redshift, and we want to talk about how federated query can be used to access data from PostgreSQL server to Amazon Redshift. Okay, so let's talk about a problem statement. So assume that you have multiple OLTP, RDS, PostgreSQL databases in place. So these are the databases where you keep your transactional data, which are then populated by your end applications. And then you have an Amazon Redshift cluster where you keep OLAP kind of data. So these are your aggregated data. These are your flattened data. So if you might be creating a star schema, and this could be the data, this could be probably your the hub part of your star your star schema. That kind of data you are keeping inside Amazon Redshift. Now assume that you have a reporting tool or you have a dashboard from where you want to query this data. So if you query any kind of aggregated data or flattened data which is inside Redshift, then that data can be served from the Redshift itself. But the moment report says that, okay, give me aggregated plus transactional data, or give me transactional data because I want to drill down further on the aggregated data, and that's where the challenge comes, that how do we solve this problem. So because your Redshift is keeping only your aggregated or flattened data, while your data sources like like in this case RDS PostgreSQL is keeping your OLTP or transactional data. So as long as my reporting tool is asking for aggregated data, I can serve from the Redshift. But if it starts asking for transactional data for the drill down purposes, then how do I solve this problem? So there are certain ways you can solve this problem, and actually federated query also solves this problem, but let's talk about certain patterns. So pattern one could be that you query your RDS databases as well. So for instance, when your report says, hey, I want aggregated data, and this aggregated data you can get from your Redshift, but if you want transactional data, you make a connection to tables, to the transactional databases, and you fetch transactional data from there. So you see the reporting tool over here is not fetching everything from the Redshift. It's getting only the aggregated data from the Redshift, but for transactional data, it's going to the actual source system, RDS systems, to get the data. Now this approach, though it works, it has many challenges. One challenge is the performance, because literally you are making multiple extractions, multiple connections from various sources, and then aggregating data in the report, which makes it a very slow in terms of performance. And the second is that it also adds complexities, because if you want to do some kind of cross join between the aggregated data and transactional data, then you can do that only at the report level. Either you will import all the data at the report level and then you will do it, or you will build that logic in the report, which makes this thing more complex, especially if you're dealing with large amount of data. So this definitely is a solution, but not a very scalable one, not a very performant one, and definitely a more complex one to handle. Now, solution 2 could be that you move your transactional data as well to Redshift. So when you are when you move data to Redshift, you not only moved your aggregated or flattened data, but you also move your transactional data. So that means your Redshift has your transactionals, flattened, aggregated, all kind of data. And in that case, of course, a report, a dashboard, if it wants both aggregated and transactional data, it can simply reach out to Redshift and get the data back. Well, again, this solution works, but it has many flaws. The biggest flaw is that your data size will ever increase, because you are not only bringing the aggregate data, you're duplicating your transactional data. You're literally duplicating your transactional data from OLTP to OLAP. So your data size is going to increase. Every transactional added, deleted, updated has to be reflected back to this Redshift cluster database. So it's really a challenge in terms of managing the data. And second is, it is going to add more cost, because you need more cost, because think of a way, the moment you add any transactional data or delete it or update it, you have to move that to Redshift cluster. It needs more nodes to manage it, and that means more cost, more data movement happening. It's definitely not a very scalable and performance oriented solution, though technically it is a solution. Okay, and that's where your third solution, which I'm going to talk about here in detail, is your Redshift federated query works, where you can keep your transactional data into your source systems, into your RDS source systems, and you can keep your keep your aggregated or flattened data into Redshift, but then your transactional data is made available at the Redshift level using federated query. So you're not moving any data, keep that in mind. You're not moving any data, but actually Redshift is actually doing a federated query to your OLTP systems, your RDS PostgreSQL server, to query data on demand. So in that case, when my report or dashboard says, hey, give me an aggregated data and transactional data both, in that case, both can be served from the Redshift. So Redshift will provide you aggregated and flattened data, which is locally stored. But for transactional data, it will use a federated query to bring data from the RDS system to the reports or dashboard. Okay. So let's talk about how this federated query works. So assume that you have a Redshift cluster where you have got local databases which you keep your aggregated or flattened data, and then your transactional data are in your PostgreSQL server databases. Now what you do is that you use a concept called external schema. So you basically create one external schema for this database over here, and then you can also create external schema for this database over here. So now you have got in this Redshift cluster, you have got one local database, which is basically local data stored, and then you have got two external schema which represent data from altogether a different database server. But now when you make aggregated or transactional data query, basically your local database can be used for getting the aggregated data, while your external schemas can be used to get your transactional data. So external schema will be kind of a local schema, like kind of a local database which you can use to fetch your data from the PostgreSQL. And the best and the beautiful part is that you can make joins between them. So if you want to make join between some table from your local database with some table from your external schemas, and you want to present that back to the report or dashboard because that is what your requirement is, that is also perfectly possible. So literally it is a way like your report and dashboard is reaching out to your Redshift cluster for both aggregated and transactional data, and then Redshift cluster in a single query can give aggregated data through the local databases, while your transactional data from the external schemas created and using federated query on top of that. So that's how exactly it works. So moving on. So let's talk about how do we configure it. Okay. So starting with the first one, so let's take step by step. So first, you have an RDS PostgreSQL server instance where you configure a security group which provides it access from the Redshift cluster. So it could be that you might want to give access. You might want to give access from the subnet in which your Redshift cluster is, or even you can look at the node level IP and can provide access at that level. But basically, you configure a security group with your RDS PostgreSQL server, which allows a network traffic or request to come from your Redshift cluster. Then you configure a secrets manager because your Redshift cluster is going to talk to RDS database, and in order to authenticate, it needs to know a login name and password to that database. And for that, we can use a secrets manager. So in a secrets manager, you create a secret where you keep the credentials of this PostgreSQL database. So the login and password of your PostgreSQL database you keep inside the secrets in the secrets manager. Then you create an IAM role, because what happens is that this secret manager will be accessed by the Redshift cluster. So Redshift cluster should have authorizations to fetch secret from the secrets manager. So for that, you create IAM role for Redshift, and this IAM role for Redshift will provide read-only access to this secret you have created, so that your Redshift cluster can use this IAM role to fetch the secret from the secret manager, to fetch the credentials of the PostgreSQL database. And then you have your Amazon Redshift cluster with your local databases, and you associate your IAM role with this database. Yeah, so that this database can use this IAM role for any authorization. And finally, what we do is that we create the external schema. And you can see over here, once you have this whole configuration you have done, you have to run some SQL statement and you can create external schema. And once your external schema is created, you can start querying both local database data plus your external data from the Redshift cluster. And this flow, guys, we are going to have a workshop towards the end of the tutorial where we are going to talk about how to configure this whole workflow. So you will get a very good hands-on experience of configuring this whole setup. So moving on. So how do I create an external schema? And it is very interesting one. So this is the kind of SQL statement you have to run inside Redshift cluster in order to create the external schema. So basically you say, I want to create an external schema. If it does not exist, you give the schema name. This is from the Postgres. You give your PostgreSQL database name over here. and then you give your RDS endpoint over here. So the endpoint for your RDS instance. Then here you provide the Redshift IAM role. So this is the IAM role you created for the Redshift cluster. And finally, you provide the secret key. So you provide the ARN of the secret key, the credential secret you created inside the secrets manager. So when you run this SQL statement, what happens? It creates a schema with this name into the Redshift cluster. So once you have created the schema, then you can query the external data with this schema, and basically this is example of a federated query. So for instance, you can run a SQL select statement saying, hey, I want to select star, or I want to select a local database, local table field, which is the local table or database inside Redshift, like example like flattened or aggregated table. And then you can say my external schema .table.field, which is my external schema representing a PostgreSQL database, and then table in that database and fields. And then, of course, you can mention both into your from statement. You can mention both into your where clause as well. So your schema, external schema, works like a local database for you, and you can make a join between your local databases and external schema data to give a result of a query back to the report or dashboard. And that way your Redshift becomes a single point which can be used to access not only your Redshift data, but also the external data which are kind of sending the aggregated data to your Redshift cluster. Okay, so what are we going to build today? And what we are going to build today is that we will launch an Redshift, we'll launch an RDS PostgreSQL database. Then we launch Amazon Redshift cluster. And then in the query editor, we'll make a federated query where it will bring some data from the Redshift local databases and bring some data from the RDS PostgreSQL server. And that will show you example of a federated query. So this is what we are going to build today in the workshop. In order to complete this workshop, I've created a workshop and I have published it to our website aws-dojo.com. Now I'm going to walk you through the steps of the workshop, and post that you can run this workshop by your own in your own time, and you follow step-by-step instructions to get hands-on experience of creating a federated query inside Redshift cluster. So let's move on to the workshop. So here's the workshop published to our website aws-dojo.com. You click to start the workshop. These are the steps you need to perform to complete the workshop. The first step is pretty straightforward. It says that you need to have an AWS account with administrative access, and if you don't have, you might want to use this link to create a trial account. Next, we create a security group, and this security group is used by PostgreSQL server to allow a network communication from your Redshift cluster. So we go to VPC management console, we say we want to create a new security group, and then in order to keep this one very simple, we simply give it a name, and they say, okay, let's allow PostgreSQL traffic from anywhere. But in actual production deployment, you might want to restrict it to the subnet of the Redshift cluster, or even the IP addresses of the Redshift cluster nodes. Since I'm using default VPC for everything, so I kept it pretty open for the workshop purpose. Then we are going to launch the RDS PostgreSQL server instance. For that, we go to RDS management console, say we want to create a new database. We selected standard create Amazon Aurora Postgres compatible serverless. So to keep the cost low, I'm creating a serverless database. I have not selected MySQL here because the MySQL federated query I think is still under preview. It is not at available for journal. It's not generally available. So that's why I'm using a PostgreSQL server at this point of time. Then we give this one a nice name for the database instance. You provide your master username, master password. I keep the capacity pretty much low, 2 to 4, or you can I could kept it 2 as well actually, because there's no load on this instance. Then I provide connectivity information, so I provide my default VPC, default subnets, and then I selected the security group which we have created in the earlier step. Since we are going to use query editor for the federated query, I'm using query editor with the RDS instance. For that, you need to enable data API. And then, we give a database name, and that is our Dojo database. And then we simply create the RDS instance. And once RDS instance is ready, then we also make note of the endpoint, because you need this endpoint later. Then we use the query editor to connect to this RDS endpoint using the login name and password. And then we create a table, say customers table. So you're saying, okay, I'm creating this script over here to create a customers table, and I'm also inserting some dummy customer data into it. So I'm just creating, example of a transactional data into my PostgreSQL server. Next, we configure the secrets manager, and the secrets manager will be used by the Redshift cluster to connect to the PostgreSQL server. So we go to the secrets manager console, say we want to create a new secret manager, say, okay, this is a credential for RDS database. We provide the login name, password, and we are saying that this credential is associated with the following database instance. And then we simply give this a nice name, and then we simply create the secret. And once we create the secret, we make note of the secret ARN, because we need that when we try to create the external schema in the Redshift cluster. So next we are configuring the Redshift role, and for that, and this role is associated with Redshift cluster, so that Redshift cluster can actually make call to secrets manager to fetch the secret credential secret for PostgreSQL database. So for that, we go to IAM management console. We say we want to create a new role, and you select Redshift customizable role. And again, to keep it simple, I'm pretty lazy, guys, when I come to documenting it. So I'm using this Postgres power user access permission over here to keep it simple. And we simply give this a role name, and we create the role. And we make note of the role ARN as well, because we again need it later. Now it's time to launch Redshift cluster itself. So we go to the Redshift management console. We say we want to launch a Redshift cluster. We give this a cluster a name. Then we want to use the free trial account to keep the cost low. The database is dev. Then we provide a login name and password over here. And then here we associate this with the role. So the role which you created in the earlier step, you associate that role with the Redshift cluster, and then you simply create the cluster and wait till it becomes available. And here I have provided some details, like in terms of login name, password, and everything for this Redshift cluster. So once this is done, what you do is that you use the query editor inside the Redshift cluster to create some local data inside the Redshift as well. And this is an example of the aggregated data which you will, or flattened data which you will use at the local Redshift cluster level. So we connect to this query editor, and we are simply creating this payments table over here. And this also has got a customer number, linking it back to the PostgreSQL server customer number. So this customer number is common here and between your PostgreSQL server table. So we create a payments table over here, and then once the payment table is created, we insert some sample data into payments table. So this is an example of creating an aggregated or flattened data inside Redshift cluster. So now my transactional data in my PostgreSQL server is ready. My aggregated data in my Redshift cluster is ready. Now it is time we create the external schema and then start making this federated query. So let's do that next. So, federate PostgreSQL database. So first thing first, so we'll connect to the, in Redshift cluster, we connect to the query editor again using the login name and password. And then the first statement we run, which is actually creating the external schema. So we are saying the name of schema is Dojo schema from Postgres, then database is Dojo database. This is my RDS endpoint, this is my Redshift IAM role, and this is my secrets key. So you can see here you provide those parameters over here, and when you run it, actually you can see that your Dojo schema is created. In fact, if you can look into the object of Redshift cluster now, you can see Dojo schema created. So now if I try to make a query saying that, okay, I want to list my customers from the Dojo schema, because remember in the Dojo database, we have created customers as a table. So now I can refer to that table using this Dojo schema, because this is the schema which is representing this database in the Redshift cluster. So I can say select star from Dojo schema customers, and you can see the result of the output of this query over here. And you can also make join with local databases. So for instance, my local database, local table is payments. So what I'm doing is select star from payments and then Dojo schema customers, where I am making join on this customer number between the local table and this Dojo schema table. And you can run this kind of query as well, which shows a result of your query where the local database and your external schema both come in the same join. So this was an example how you can use a federated query. This pretty much closes the workshop. Then you follow the next step to clean up the resources so that you don't incur any cost post this workshop. And that is for all today, guys. This was an example of using federated query. I hope you liked the video, and if you like, please click on the like button. Please subscribe to my channel, and there are many other such similar workshops and exercises which you can use in this website aws-dojo.com to learn about AWS services. Please do explore that. We always look forward to your feedback, whether it is for new content or certain improvement we have to make or some mistake we have made into our video. We always look forward to such feedback. You can provide such feedback either in the comment section of the YouTube channel, or you can also provide us by clicking on this contact us tab over here and can provide feedback from there. So we always look forward to your feedback to make our tutorial more and more suitable to you and more meeting your demands, your requirement. I promise to come back in a couple of days time again with another video, another tutorials. In the meantime, please stay safe and have a nice day. Bye-bye.